we all know these visions of killer robots or very gentle robots helping us to go to space and land on another home planet. But I'm not going to talk about these visions, what eventually might happen. I'm going to talk about how it affects the tech industry today. And also going to give you some insights how it affects us at KONUX. Yeah. And my subtitle is the key message today, from student to teacher, which means that companies will have to transition from perceiving themselves and being a student in their respective fields to being a teacher. And I think this image here represents this quite well, that there will have to be more of an idea that you actually work together with your machines, which become more and more powerful and more intelligent. All right, to give you an outline. Oh, it's still connected to the other one. Well, that's fine. First, we're going to talk about some definitions. Slightly philosophical, but I think it's important to have a common ground and a common understanding what intelligence is, what learning is. Then I'm going to move on very quickly to some major misconceptions about artificial intelligence and machine learning, just to get this out of the way. What is AI capable of and what is it not capable of? And then, of course, focusing on this from student to teacher message. And finally, going to give you some insights, as I mentioned before, what we do at KONUX actually. Alright, let's jump into the definitions. Now, first of all, many people use machine learning and artificial intelligence as synonyms, which I think should be the case. I think you could rather connect them well with the sentence like this: a machine has to learn in order to become intelligent, or an artificial intelligence. So far so good. Now, what is learning, what is intelligence? I think we all know what's meant by machine and what is meant by artificial. So let's first have a look at intelligence. And I tried to gather some definitions of popular sources. So Wikipedia, Quora, I think everyone knows Quora. It's a forum where people ask questions and then you can rank and vote for the best answers. And finally also some expert scientists' opinions, mainly from TED Talks or some other expert forums. Okay, so for Wikipedia, intelligence is basically you gather information, you somehow store it, you save it, and then you move on to using this knowledge to adapt your behavior in a new or existing environment. Quora says, like, Wikipedia is quite generic. Quora is the best answer to someone asking what is intelligence, or actually I think that person asked what does make smart people smart. So someone said that intelligence, for example, when you do an IQ test, when you do an IQ test, it only will tell you that you're intelligent in a certain narrow field. So it's always like that also in machine learning development. You don't have these crazy machines, even if some companies claim that they have them, which can do everything. No, you have a certain narrow AI, and it's only capable of excelling in one specific field. And finally, this is actually a very beautifully elegant definition of intelligence. I think a friend showed me this some months ago. I think it was a TED Talk. It was by a very bright mathematician, and this is actually coming from a very short formula. And basically what it means is that when you're intelligent, you always try to maximize your future degrees of freedom. And I think we all know that, and I would even say that any machine learning or artificial intelligence developer, or basically any person who tries to generate something new, if they incorporate this sentence into their core work culture, I think chances are pretty good that you will do the right thing. Alright, now what about learning? How do you get to be an intelligence or to create an intelligence? Again, Wikipedia, Quora, and scientists. Wikipedia says learning is modifying information, right? You go from one stage to the next. There's definitely a learning curve to it, and it all doesn't happen at once. So we all know these learning curves. You know, a system is getting better and better at doing something. In the beginning, it learns very quickly, but to really get to perfection, you need a lot of time. And very important as well, it's shaped by previous knowledge. Yeah? This is also how it's happening in machine learning. If you train a system and you've began to train it in the wrong direction, it's really hard to get to the right path again. So the same holds true for teachers teaching students, right? If you teach them some crap for years, it's going to be really hard to put them on the right path again. In Quora, someone says, not totally different, only thing is that they focus on the brain. Now, quickly discussing brain. Many people think that if you talk about artificial intelligence, it's all about copying the human or the mammal brain. Now, who are we, mere humans, to think that what evolution created on our little planet is the holy grail of intelligence? Maybe there are even completely different forms of intelligence. And actually, neural networks, which are like really inspired by this, are only one narrow field in the vast sea of machine learning algorithms. I actually just came back from a 2-week machine learning summer school, and there are so many different approaches which are completely non-inspired by biology. So artificial intelligence really is not connected to this mere idea of copying the brain. And finally, a scientist, or actually maybe here in this case a mathematician, will say you have very clear procedures on how to train a system, how to make it learn. And here the 3 big topics or the 3 big applications of machine learning are being named. Pattern recognition, so basically in dynamic system you want to detect patterns. You want to be able to classify stuff, so saying is it a cat or is it a mouse in this image. And of course, very complex, yet very precise calculations. All right, so now we have a common understanding of what intelligence and learning is. Let's talk about some misconceptions. First of all, when we as KONUX present an artificial intelligence involving products to our clients, the first thing that comes up is, oh, but it's a black box, we don't know what it's doing. It might suddenly do unspeakable things, and a hand might get cut off. Maybe not that extreme, their concerns, but it gets in this direction. The second thing is that many companies claim, like Google DeepMind, to have developed something that is capable of doing anything. And you don't even need training data anymore. It's completely unsupervised. You just put it in a system and it learns to do anything to perfection. And finally, is it better than a human or not? This is a question which many people also ask themselves, like, will they ever be able to do something like love, like creativity, curiosity? Will they be able to write poetry? So the black box, you can say that machine learning algorithms will definitely learn something which you as a human will not even be able to understand, and it doesn't even make sense because, I mean, of course, even a huge neural network is essentially one single formula which is smooth in any way. But many people, I think, tend to confuse black boxes with instability. And actually, we at KONUX have made the experience, and I think many other machine learning developers can say this too. There are many tools by now from research and development from the academic world which you can use to make sure that your system will not do anything that you can predict it will do. So this concern, you really have to separate black boxes, you know, that it will know something that you cannot understand anymore as a human, and that it will do something completely unpredictable. The second, as I already mentioned, it's not true that companies have already developed the holy grail, like even AlphaGo. I mean, of course, it's capable of doing something really, really great, and it could be applied to many other things. But right now, it's just applied to one thing, and it cannot do 2 things at one time. This is mainly due to not quantity, but quality. We still haven't quite figured out how to scale systems a lot, and so on. But you can definitely say that the results are still very, very surprising and surpass in many ways human-like learning. Finally, I listed some things that many people, or most people, would say machines can never be curious, can never be creative, can never write poetry. I put poetry here for a reason, because poetry actually is a synergy out of many, many human things like love, vision, also curiosity and creativity and everything, right? There's a TED Talk, for example, about a machine that has been reading millions of poets, just like a master poet would also do before he excels in his field. And basically you have a human audience like here, and you show them a poet, and then they have to decide whether this has been written by a human or a machine. And in over 60, maybe even 80% by now, they're still improving, of all cases, the human audience would say this has to be done by a human because it's so good and makes so much sense and it's so full of passion and so on. So this is solved. Yeah? Curiosity. You put a robot in a field, it doesn't even know what to do with its arms, yeah? It just knows it has motors, and suddenly after a couple of iterations of learning, it learns to walk and it learns to get to the food and so on. Yeah? So yeah, curiosity is definitely also something that is not limited to humans. And I think the most solved thing is definitely creativity. You might have heard about this, yeah, actually I think it was at Google DeepMind where they built a model which was unsupervised, or well, only realized through reinforcement learning, and they let the system play old Atari games, and the only input was the screen, and the reward was to maximize your score. And it was able to find ways of playing this game which the computer scientist nerds never could have thought of. Yeah, it got really, really creative. And so if a human would have found this technique to play this game, to excel in this game, we all would have definitely said, oh, that's a creative person. So also pretty much solved. Okay, now the main message. Most companies today probably are still tackling technological problems like this guy here. Okay, you sit down with your 15 billion neurons in your head, running at 100 hertz each, and you're trying to think, okay, how am I going to solve this? And then it takes ages. And what humans always tend to do is find the most simple answer. For example, you could ask very wise and old farmers how to predict the weather. So some might tell you, oh, you know, if the squirrels are running around like this today, tomorrow there's going to be sun. Others might tell you, I can feel a certain chill, so tomorrow it's going to snow. And the third one might tell you another BS. So, you know, humans tend to simplify it. And of course, all of them are right and not right. But it would be much better to have a machine which is like, does not always try to lower its energy level, but is actually able to link all indicators and to make the best out of that. So there will have to be a shift in companies' philosophies. So first of all, the teacher aspect. Big companies are still students in their respective fields. They try to understand everything. They try to still be in charge of their intellectual core property. They try to do it themselves. And they can't stand the thoughts, especially senior people, to build something which they cannot understand anymore. But actually, now we're in the era of machine learning. So you have to let this go. You have to say bye-bye to understanding everything. But you have to understand that you have to become a nurturing teacher, yeah, and then create a nurturing environment for your student being the machine that has to learn something. Then the IP, which I already mentioned, it will definitely happen, and at KONUX it's already kind of happening that you don't know anymore exactly how this measurement principle is being realized in this neural network. And it doesn't matter, because if a teacher is teaching a student and he knows after some time that he excels in math, and then some company comes by and asks the teacher, hey, do you have excellent math students? Well, yeah, this guy. No one of them, maybe not even the student himself, will understand why they excel at math. And it doesn't matter, because you know that you taught them exactly what to do. And this is enough. And finally, communication. This is, I think, actually a really major point that, especially in bigger companies, and this is, I think, where startups really have an advantage, the communication is really poor across departments. You might have, in one research big department, you might have sub-departments where some guys are doing the hardware, other guys are working on the mathematical models, and yet another group is working on, I don't know, generating the training data. And they all have no clue of each other. And this is actually really true for some companies, as I also learned from a couple PhD researchers when I was at the conference. Now, how do you benefit from this shift in philosophy? First of all, the cost will go down. You will be more optimistic about your development and research. and the adaptability of everything you do will increase as well. Cost, well, it's pretty clear. Before you had to sit down and think as a human how to solve it. Now you can actually just train a machine learning model to do it, and this can happen very fast. Especially in our case, for example, we're a sensor company, so in order to test our precision products, of course we're going to have test benches, we're going to have really expensive reference hardware to really test whether you can trust your results, you can trust your outputs. And so if you know what's going to come in and you know what has to come out, just train a model for it. Yeah? Don't sit down yourself and come up with this formula. Just train a model and it'll be done in 5 minutes. Yeah, it's really like that. It's been like that for us as well. Optimism, yeah. Before you would say, oh, I can't understand this. Like, this is way too complicated. Even the brightest member of your company research team is not able to understand this. Well, it doesn't matter, because as long as you have training data and you know how to set up your environment the right way, you can still find maybe a neural network or a random forest or some other machine learning model to actually get it and to realize and solve the problem. Adaptability, as I already mentioned, humans tend to simplify and also stick with their solutions. So if you have a machine, it is completely indifferent to change. You can tell it somehow, oh, okay, now actually this sensor, for example, in our case, will be deployed in an environment with a lot of temperature changes, so you should also add as yet another dimension temperature to compensate for it. Well, just do it. Yeah. While a human might think, oh, now I have to change my whole formula, how am I going to integrate temperature, way too complicated, not going to do it, I'm going to miss some customers. Okay, now, what do we actually do at KONUX? So at KONUX we try to really do the whole vertical approach. We try to work with novel AI, we build the hardware which our AI models exactly need, and we work on real problems. So for example, we use decision trees, neural networks. We really try to have a good understanding of a very broad range of different tools, which I think is really important. As I already said, not all models are inspired by the brain. Yeah? There are some other things like Gaussian processes or decision trees, which really are coming from a different philosophy. And if you have your hands on many tools, which today is really not hard, you just download a Python library and you have it. I think you have very good chances of solving a lot of problems, whether it's in supervised learning, unsupervised, reinforcement learning. Second, you can see here some hardware that we're testing actually for an optical measurement principle. Yeah, this is important. You have to build the hardware so that your model feels home in its environment where it's running on. Yeah? This will make a lot of problems a lot easier. For example, we had problems with noise on our data. Now, a company which would solely focus on software, on data analytics, they couldn't do anything anymore. If the noise level is too high, you cannot retrieve the information and that's it. Of course, you can average over it and so on, but at some point you're just limited. In our case, we could just say, okay, let's adapt our electronics. Let's put some really nice analog filters on the PCB and we're good. And even if some bigger companies might be able to do this, the communication all the way from a mathematician to someone designing the PCB, forget it. It's going to take ages and it's not going to happen. And finally, I think even though we're like really into machine learning and everything, I think the cost function that we always try to optimize is bringing the best solution to our customer. Yeah? And this is definitely also something that many companies still have not really understood as well. I also talked to some people from a very big German engineering company, and I mean, you talk to people who are working on problems which could actually directly be applied to some problems that our customers have, but you ask them, okay, on what kind of data do you work on? Yeah, it's just some synthetic data. I just created it myself, it's random stuff or whatever. It's ridiculous to some point. Okay, to finish up, some key takeaways. First of all, intelligence is not some cloudy thing that you can't really grasp. You can definitely define it. You can define it in philosophy, you can define it through math, through formulas, and it's really something that you can optimize mathematically, systematically. Also, machine learning, yeah, it really does offer a lot of advantages, and I'm very sure that as I speak, there are millions of people working on problems which could be solved in maybe a week just using machine learning. Because they probably have some training data, because they need to test it against some reference. And all they're missing is basically, the knowledge, of course, of machine learning. And I think companies should do way more in training their people in these fields, because it's really not as hard as you might think. And of course, start to think more like a teacher to your student being the machine. Don't try to solve every problem yourself. You're just a human, you're limited in your capabilities, and there are many mathematical models out there which, of course, are not superior to yourself in terms of quality, but definitely in terms of quantitative performance. For example, if you want to predict how to, I don't know, catch a ball with a robot arm, you train it for a couple of times and it'll get it from the images that it records with its cameras. Don't build a formula yourself. And finally, not to forget, KONUX is hiring. We're looking for very good people. So if you're interested in joining us, we're growing fast, and I'd be glad to talk with you about it. Thank you very much.